Welcome everyone back to 3 Inquisitive Kids, and this is problem 3 in our fraction series. So we have 1/8 plus 1/24 plus 1/48 plus 1/80th plus 1/120th plus 1/160th plus 1/224th plus 1/288th. So our first step is to find the golden sequence in here. Well, I don't see 2 or 6 or 12 or 20 or 30 or 42 or 56 or 72. But where are they hiding in this sequence? First, did you notice how I was writing the numbers down, each below each fraction? So let's look at the denominators. 8. 8 is exactly times 4 of 2. 24 is also exactly times 4 of 6, times 4, times 4, times 4, and so on. So that's where the sequence is hiding, in the denominators. It's just that it's not direct because each of them is multiplied with a 4. So there are actually 2 methods to solve this problem. I'll call this method 1. Method 1. First, we're going to have to remove all of the 4's out using the distributive property. Only this is on the denominator, which means that the fraction that's being factored out is actually 1/4, not 4. And what's left in the parentheses is 1/2 plus 1/6 plus 1/12 plus 1/20th plus 1/30th all the way to 1/72. So we're just going to leave the 1/4 outside for now. And you know what to do with the parentheses. So it's great if you can pause the video and try to calculate the parentheses by yourself. Yeah, so this isn't really anything different, right? We can turn this into 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 all the way to plus 1/8 minus 1/9. So again, same steps, nothing new. We're just splitting up the fractions. And now what we can do is cancel all of these out. Great. And we're left with 1/4 times the difference of 1 and 1/9. So 1 minus 1/9 is 8/9. 1/4 times 8/9, we can simplify. The 4 is canceled out with 8. 8 has a 2 left. So our final answer is 2/9. This is our final answer. But again, this is only our first method. What's another method? Okay, so this is method 2. Again, we're going to get the same answer, 2/9. But this is just a better way to challenge your brain as well. Okay, so the first step is again to look at the denominators. But this time, we don't need to worry about factoring out anything because we're not looking for specifically the golden sequence. The golden sequence, yes, it can cooperate with canceling out fractions, and that's a specific type group of numbers, set of numbers that we're looking for when we're doing that. But that doesn't mean that that's the only set of numbers that we can apply the canceling out fractions with. Many other fractions can also do this. For example, the one we're given right now. 8 can be split into 2 times 4 on the denominator. 1/4 is split into 4 times 6. 1/48 is split into 6 times 8. 80 is, 80 is 8 times 10. And all the even numbers. Just keep going on like this until we have, right over here, this is 10, 12, 12, 14, 14, 16, and over here would be 1 over 16 times 18. And then we just have 1/2 minus 1/4 plus 1/4 minus 1/6 plus 1/6 minus 1/8 all the way up to 1/16 minus 1/18, right? So we're applying the same solution to a new type of sequence, which is this even numbers sequence. Again, this can be split up. This is just like another variation of our golden sequence, but sometimes you don't need to apply the extra step of the distributive property. You could just do this right off the bat. So if you know that this is a variation of the golden sequence, then ultimately you can do it. So we cancel all of these dominoes out and we have 1/2 minus 1/18. So again, calculate and we get 2/9. So that's again our final answer, 2/9.